Tech Nuggets, DHCP. DHCP helps solve one of our chicken and egg problems when it comes to even small networks have this problem, like at your home or somewhere like that. It solves this problem of plugging a new machine into your network and how does it get an IP address? Clients and servers both need IP addresses, but the truth is we only really care what the IP address is of the server. Clients, which are the vast majority of machines on the network, really don't care what their own IP address is. They only need it so that they can have unique communication with a server, a printer, a file server, a web server, some other device that's offering a service. And in that case, those devices on the network need unique and non-moving IP addresses. And we'll talk about what non-moving means. So it helps solve this chicken and egg problem. DHCP stands for Dynamic Host Configuration Protocol, and it helps dynamically configure an IP address on our client machines. When we do the Wiresharking later, we'll see this other acronym called DORA, and some people confuse it. That stands for the 4 packets that go on in the Wireshark that we'll see, which is a discover, an offer, a request, and an acknowledgement. A little bigger discussion about where does DHCP fit into our IP architecture, and that means like when we've laid out our subnets and we're allocating IP addresses in our documentation, where does DHCP fit? And earlier in our subnetting discussion, we talked about this convention that we use. And normally, static addresses are at the very beginning of our subnet, and we may or may not have a gateway that's the last usable address in the range. That happens to be the convention we use. It's not the convention everyone uses. But DHCP, and they're called DHCP pools or lease pools, tend to exist in between the statics at the beginning of the range and maybe a small range of statics at the end of the range. And they kind of live in, well, ranges, long groups of them that would be in there that our DHCP server will use and hand out and recover. And that's what our DHCP server does, is the client and the DHCP server have a discussion, and the DHCP server gives the client an address for a certain amount of time. And the client may leave and come back and that kind of thing, and it may get the same IP address or it may not, which is the joy of DHCP. The DHCP server will recover those addresses and reissue them to new clients as needed. If we have too many clients, we'll exhaust the pool, and then we have a problem because the DHCP server will run out of addresses to hand out if there's too many clients that show up. This can happen in a wireless interface, so that tends to be where we get lots of phones and laptops and tablets, and they show up and all of a sudden, wow, I ran out of IP addresses. I didn't realize that. So some amount of monitoring of our DHCP server is required. Our DHCP server can also hand out things called DHCP options. So other things can be handed out with the IP address. What are my name servers? What's my gateway? If we're a specific device, and the VoIP telephones tend to be this way, where can I find my SIP server? Where's my TFTP server to begin to pull configurations for my handset? Things like that can also exist in our DHCP server, and so handing out DHCP options is not unusual. When we get to the practical piece at the end here, I'm going to use VyOS to implement a very simple DHCP server, and we'll do that in GNS3 with some practical demo and some Wireshark so that we can see DORA and we can see some of the options fly around and things like that. So on to the practical part. All right, so I've set up a kind of a small network like you might have at home. Using a VyOS router here, and we've got a cloud that represents our internet connectivity. Comes down to VyOS ETH0, that's a little E0 here, and VyOS is going to act as our DHCP server, as our default gateway. It's going to actually work as our NAT, which is a different tech nugget that we'll get into a little later, and it's going to provide LAN connectivity out Ethernet 1, which is on this side to this little switch, and then off to our VPCS. And we can see that I've got it configured here for DHCP on ETH0, and I've set up ETH1 on our LAN side as 192.168.1.254. That's our gateway's IP address, which follows our standard. If you come over here to the VPCS, VPCS is a very interesting little test object. Does a nice job at just doing basic testing kind of things. It makes very little assumptions, so when it comes up, it doesn't have any network connectivity. It doesn't attempt to be a static IP address. It doesn't attempt to do DHCP. It just kind of turns itself on, and you have to tell it everything you want. So if we do a show IP, we can see here that it's going to give us its name and its MAC address, and it really doesn't know anything else. And that's pretty standard for what we'd expect with a VPCS. It's a great little test object. So let's configure the DHCP server, which is really only 2 commands to do the basic function of handing out IP addresses. Set service. And I'm a big fan of tab completion, so sometimes when you see the word just appear, that's because I hit tab and it knows that. Sometimes if there's multiple options, it'll show me multiple choices. So we say DHCP, and there's 2 options. So I put yes on it. It says server and shared network name. And here's a point where I have to pick a variable. I tend to pick things like LAN pool. Very exciting. If it's got a space in it, you may need to put quotes around it or tick marks around it or something like that. I tend to go with dashes. That way it's all one text string and the spaces don't confuse it. But every time I work with this, I'll start every command with this set service DHCP server shared network name LAN pool. Because I'm referring to that pool of IP addresses. I can have multiple pools. If I have multiple interfaces, I might want to do that kind of thing. And in fact, we'll actually refer to it by LAN pool and by the subnet that it's working with. So all of my commands will start with pretty much that. We're going to set the beginning of the range. So it's range 0 in case I have multiple ranges. I have range 1, range 2. We're going to have range 0, and we're going to say what IP address in that subnet do we want to start handing out IP addresses from. In my case, I'm going to pick 128. So that's halfway through the range, right? We go from 0 to 128. That's halfway through the range, and I start handing out IP addresses at 128. When clients show up and start asking, they'll start getting 129, 130, 131. It usually hands them out in order. So we say start, and that's the beginning of the range. One of the other things I tend to do, and this is an up arrow key, it brings back the previous command, which is really great because I can use arrow keys in this case to go back and do things like that. And we're going to say, where's the end of the range? So we get rid of 128 and we put in 250. So this will give me a range from 128 to 250. Now our default gateway in this case is at 254, so we don't want the pool to include things that have static IP addresses. That'll get real ugly when the DHCP server hands out an IP address to something that's statically assigned. There'll be a little battle and both people will lose. So we'll make sure our pools don't overlap with any statically assigned IP addresses. Documentation in this case will be very important. So we'll set it at 250, which will give us a good deal of IP address space to work with in our pool. We've got it in there, and if I do a show at this point, you'll be able to see what's going on. You can see all the little pluses here mean I've added the command, it's accepted the command, but I haven't committed the command. So I will type commit, in which case it will actually go and take all those commands and put them into action. And until I type commit, it doesn't do it. So we'll come back over here to our VPCS, which has no IP address, and to get it to pick up an IP address, we type DHCP. It's pretty straightforward. Every time I type the word DHCP, it will go through the complete acquisition process of getting an IP. So we'll go through DORA every time I type DHCP. If we want to see a renewal, we'll have to wait for it to happen, and we'll get to that a little later when we do some Wiresharking at the end. So we can see it went through the DORA process. We can see it went through 2 discovers, an offer, a request, and an ACK. And if I want to see what it got, I can type IP, and there show IP, and it'll show me the IP settings that it's got. At this point, we can go back to the DHCP server and get some information out of it about what does it know and who has it seen. Unfortunately, we can't do that in config mode, so I'm going to have to exit config mode, and it'll complain that my server, my settings haven't been saved. In real life, definitely, before we leave commit mode, we'd type save and it would write it out. Then if the router reboots, it'll save it all. I'm in a lab environment, so I'm not super worried about it. If you're using GNS3 and you're going to shut it down for the night or something, definitely save. Otherwise, it won't be there when you come back, especially if your VM needs to be recycled or something like that. So make sure you save your settings. It's always good practice. So if we want to see what's going on, we're going to use the show command, and we're going to show DHCP. And when I type, I hit tab, it's going to ask about being a client and being a server. So we want to know about the server since we are the DHCP server. And we can ask it a couple of things. We can ask it about leases that it's handed out, and we can ask it about statistics. In our case, we're going to ask statistics first, and we'll come back to leases. So basic DHCP server statistics are going to just tell me about the different pools that it has. So in our case, we only have one. It tells me about LAN pool. That's the variable I picked for the pool name, how big it is, how many leases have I handed out, how many are available left, and then of course it calculates a percentage. If you had really busy Wi-Fi networks, like at a coffee shop or a public place, public library, you might worry about IP exhaustion. As people wander by and lots of people are picking up IP addresses, if your lease times are set very long, we may run into what's called pool exhaustion, where we've run out of IP addresses and then nobody can get one until some of them expire. And again, how long your lease times is going to be a dogs playing poker discussion. What do you need is based on your business case. So if I'm a public library or coffee shop, I'd set it down to 3, 4, 5 hours. And if it's more professional setting where I don't expect a lot of churn in my devices, maybe a couple days, a week, something like that. Your mileage may vary. It's going to be depending on your business need and how it's worked. So we look at these statistics to try to understand what's going on so that we can go back and change them. So the other one that we're going to look at, and I did an up arrow here and then I'm just backspacing, is leases. And it'll tell us about the actual leases that it's handed out. It'll give us an IP address and a MAC address, when it's going to expire. This one expires in another day or two, so it looks like we're set up for maybe 24 hours for a lease in this case. The name of the pool, and then the client that showed up. And this PC11 kind of matches with what we're seeing over here in the VPCS, where it kind of looks like PC11. Apparently the DHCP server doesn't like brackets in its names, which isn't terribly surprising. So it's going to show you some of that kind of information so you can see what's going on with your DHCP server. And that way you can manage the pools and manage your resources and understand what's going on. Again, good documentation is going to be really important here. So you'll want to keep track of all that kind of stuff. I should have mentioned earlier, at this point in the process, our VPCS has the most basic version of an IP connection in its LAN context. So we should be able to go and do things like this. And this is the most basic test you can ever run. And it's the first test that should be the first thing you try. Have you pinged your gateway? And I can ping my gateway. This tells us the most basic discussions of, is the VPCS set up with the right settings? If we immediately try to ping the internet, it'll fail. And if you know anything about the network, you'll know why. There's no gateway configured. DHCP isn't currently handing out a gateway. That's an option. It's an extra that the DHCP server can do. So we always ping our gateway first because it tells us the basics of, is my computer configured correctly, and is my next hop, the thing that I have to talk to be able to get out to the rest of the world, is it up and functioning? And if I can ping my gateway, that's the first step to onto the rest of the world. So let's go back and we'll add the options to add a gateway to our DHCP server. So we've got to go back in config mode, and then we say things like set service DHCP server, let's see, shared network name. And at this point, if I hit tab, it'll know that LAN pool is an option. Because I've added it and used it once in a committed fashion in my config, it'll actually pick it up and let me tab complete with that. So that's worth knowing. We have to give it a subnet. And again, if I hit tab, it will know that that's a subnet that I've used. Now at this point, we get into the actual options for what we can do. And we're going to tell it, if we hit tab here, we get a lot of options. We get DNS servers and domain names and all sorts of other kind of crazy stuff that goes by. In our case, we want default router, because that's the same thing as a default gateway. And we're going to tell it exactly the IP address that we want to use, which in our case is us, right? We're the default gateway. The VyOS box is the default gateway out of the network. We hit enter, and we commit it. And at this point, the VPCS doesn't really have any idea what that setting is. It's never gone back and asked. Now, we could wait for a renewal, but if you look up here, we're going to wait 12 hours because the renew time is a day, which means every 12 hours it goes back. It goes back at half the lease time and asks. We can force that by just typing DHCP, and it'll redo the entire DORA process and force the pickup of the new default gateway, and we don't have to wait. And show IP, you can see now I've got a default gateway. I can get out to the rest of the world. So I should be able to ping, this is Google's name server, and I'm referring to it by IP, and I could ping it, right? That means I've got an IP connection to the rest of the world. I can't resolve names at this point. If I did this, it'll fail. There's no name server. It doesn't have any way to resolve it. So let's go back to our, DHCP server and hand out some, hand out some other stuff. So we go back up, and all I did was up arrow. We're going to back up over default route, and we're going to say DNS. And we'll be able to put in a DNS server. In our case, we're going to use the university's DNS server. And we'll commit that. And we'll go back here to VPCS, and we'll force it to redo its DORA. And it'll have a name server. So in this case, we should be able to do google.com, and it'll resolve a name at this point. So as we hand out more and more options to the clients, they get more and more functionality. Certain clients are going to need specific options. So if I had a VoIP telephone, it's going to need to know where its SIP server is, and that might be an option we hand out in our DHCP server as a special option. And the phone may ask for it, and the DHCP server will give it to anybody that asks for it, and the phone will probably be the only person that asks for it. But we can do different options for different needs. As part of our DORA process, different options will get asked for by the client, and they'll only get the ones they ask for. There's some basic ones that the server always hands out, like an IP address. But there'll be other ones that the client asks for. And when we do some Wiresharking, we'll be able to see how that works. So one of the things we want to do in our lab context is shorten up our lease times, because it's just way too long to wait a day. We want to Wireshark a renewal here in a little bit. So we're going to shorten up our lease time to do it. And lease is an option, and we're going to say 120 seconds, because lease times are always measured in seconds. So we'll say 120 seconds, and we'll commit it. And again, that option does not get pushed to the VPCS until it hits a renewal, which is going to still take 12 hours, or we force the cycle to happen again, which we'll do here. And we'll be able to see its lease time will change. You can see it here is set for a day. And when I do show IP, now it's set for 120 seconds. That's what 120, 60, and 105 is, that kind of thing. It's telling you how long it's got left. So I've rearranged some of my windows here to make it a little easier to work with, and we'll be able to see things going on. VyOS is still running. I just sort of minimized the command window in the background, and we've reset our VPCS here to blank, so it doesn't have any IP addresses. What we're going to do here is we're going to watch it do an acquisition, an initial acquisition. So we're going to move the mouse. It's really tough to get to, but when it turns red, we're going to right-click on it, and we're going to say Start Caption. It's going to start Wireshark. We want to make sure the little checkbox for Start Capture Visualization program is running, and for us, that means Wireshark. Sometimes it starts, and sometimes it doesn't. You'll notice the little magnifying glass comes up, and we right-click on it, and we say Start Wireshark, and then magically it'll just start. It's a little iffy on that one. I'm not quite sure why. We're going to go back and select our VPCS, and you can see here we're capturing little magnifying glasses on there, and when we type DHCP, we'll start seeing packets go across. So we can see a variety of different things going on our network here, as it does a couple different things as it goes along, and our DORA finishes. And I'm going to clear the IP really quick so that we don't get any additional data. Normally you wouldn't do that, but I'm going to do that just for the sake of what we're looking at here. So we come over to Wireshark, and we can see there's 3 panes, and I've sort of made this one on the bottom. This is the raw data pane, and it refers to the actual ASCII binary that went across the wire. Binary goes across the wire, ASCII does not. And I minimize that because we really don't need to see that in this case. This is our summary pane up at the top, and it's showing us all the data. None of it's filtered, so we can apply some data or display filters, which we're going to do here in a minute. And then depending on which packet I have highlighted, I may see a variety of different things. So I highlighted this number 3 packet, and we can see some things here. And if I highlight a different packet, I'll see some other. These are packet options. For now, what we want to see is DHCP packets, because that's what we're talking about. So we're going to go up, and we're going to put in a display filter to suppress everything except the DHCP packets. DHCP is based on an older protocol called Bootstrap Protocol, or BootP. So for some reason, the filter is still called BootP. It does not call DHCP. You'll notice when it turns green in the background, that means I have a legal filter, and I type in BootP and I hit enter, and whack. All I'm looking at are DHCP packets, or BootP packets in this case, both. And we can see some interesting things. So we highlight our first discover really, and we open up the Bootstrap options here, and these are the things that the client is asking for. So this is VPCS is 0.0.0.0, and it's asking everyone. So this is broadcast traffic. It goes out to the entire network. It's very chatty. It's one of the reasons we want to keep our lease times longer, because we want less of the broadcast chatty traffic. There's always that balancing act of too long, not long enough. But so this is the things the client's asking. It's saying, hey, I'm out here, I need these things, and I need an IP address, and I need some of this other stuff, and I'm asking for these options. I'm asking for a host name, I'm asking for some of these other options down here at the bottom. What we see come back from the DHCP server is an offer, and it says, hey, these are the things I already know about you because you gave them to me. You gave me your MAC address, so those kind of things I can tell you, and these are the options that I have. And they're all numbered, and these are the options that I can hand back to you as we go along. And the client responds and says, well, these are the things I want. That's why it's a request packet. These are the things I want. Now that I know what you have, these are the options. Send them to me. And the ACK will respond with all the things that it can respond with. So there'll be options in here for what's my router. And if we open them up, we can see the router. This is the response that comes back. My lease time. How long is my lease time? All those kind of things come back in the ACK. And that way we can see this back and forth go on. Some of it's broadcast, some of it's not. We're, using DHCP gets us to a point where we can do globally unique identifiers for IP addresses, so we can have conversations with the whole world, but we can also have LAN conversations that aren't blasting traffic to the entire network, which everybody has to listen to and then throw away, which is ultimately bad. So once again, I've kind of reset everything back to the beginning so that we can kind of see it from the beginning. We're going to do basically the same thing, although in this case, we're going to let it continue to run, and we're going to watch the renewals happen, which should happen every 60 seconds. So we're going to start the sniff, and we'll start packet capture, and Wireshark may or may not decide to grace us with its presence, which it looks like it hasn't. So we'll right-click and say Start Wireshark, and it will begin to do its Wiresharking thing. And we'll go to our VPCS and type DHCP. And we'll see DHCP start happening. And we'll type boot P for our filter. That way we don't have to watch it. And we'll probably it'll take 60 seconds or so. So we'll probably do a little time compression on the video so that you don't have to sit here for 60 seconds in the quiet. All right. And there you can see at about 60 seconds, 62 seconds here. It's 4 seconds when we got our IP address, and then another 60 seconds later, you can see we do a request and an ACK. And when we open those guys up, we can see this is what the server's telling you it has, and our ACK is saying, yep, those are the things I'm going to use. This process would allow us to update options if we needed to. We'd be able to say, okay, I need to change the lease time, or I need you to give up your IP address, or things like that. We'd be able to change options as we went along. I hope you've enjoyed this Tech Nugget. We'll have more in the future on NAT and DNS and a variety of other topics. We use some of those concepts in this Tech Nugget, but we'll cover them in detail and how they work and things like that in Tech Nuggets coming up. So stay tuned.